Welcome. We will now review AWS CloudFormation best practices and troubleshooting for templates. You might want to consider these ideas for organizing your AWS CloudFormation templates. As your stack grows in scale and broadens in scope, managing a single stack can be cumbersome and time-consuming. You can group resources with common life cycles and ownership. This way, resource owners can use their own process and schedule to make changes to their resources without affecting others. After you set up your stacks and resources, you can reuse your templates to replicate your infrastructure in multiple environments. For example, you can create environments for development, testing, and production. Before you launch a stack, check that you can create all the resources you want without exceeding your AWS account limits. These service limits might impact the deployment of your AWS CloudFormation templates. You can use AWS Trusted Advisor to verify the limits will not be exceeded. If limits will be exceeded, you can request a service limit increase from AWS support. You can also use AWS organizations together with AWS CloudFormation. Using both services can help ensure that infrastructure created on separate accounts all follow the same policies and organization-wide controls. Here are some of the best practices for creating AWS CloudFormation templates. Avoid embedding credentials in your templates. Instead, use input parameters to pass information when you create or update a stack. By using parameter types that are specific to CloudFormation, you can quickly confirm values before resources are created. If you use parameter constraints, you can describe allowed input values so that CloudFormation catches any invalid values before it creates a stack. Use AWS CloudFormation init to deploy software applications on EC2 instances. That way, you can describe the configurations that you want instead of scripting procedural steps. Finally, always validate templates before you use them. Validating a template can help you catch syntax errors and semantic errors before CloudFormation creates any resources. Here are some additional best practices for managing your stacks. After you launch a stack, use CloudFormation to update resources in your stack. Do not make changes to stack resources outside of CloudFormation. Doing this can create a mismatch between your stack's template and the current state of your stack resources. This can then cause errors if you update or delete the stack. You should create change sets before you update stacks. With change sets, you can see how proposed changes to a stack might impact your running resources before you implement these changes. AWS CloudFormation doesn't make any changes to your stack until you run the change set. This enables you to decide whether to proceed with your proposed changes or create another change set. Stack policies help protect critical stack resources from unintentional updates. Specify a stack policy when you must create a stack that has critical resources. AWS CloudTrail tracks anyone who makes CloudFormation API calls in your account. To help gather information, enable logging and specify an S3 bucket to store the logs. You can then audit who made which AWS CloudFormation calls in your account. AWS Config can also give you visibility to what changes are being applied to your infrastructure and allow or deny those changes. Finally, use code reviews and version control to manage templates. These methods help track changes between different versions of templates. This in turn helps track changes to stack resources. Also, by maintaining a history, you can revert your stack to a prior version. If AWS CloudFormation fails to create, update, or delete your stack, you can view error messages or logs to help you learn more about the issue. The AWS CloudFormation Troubleshooting Guide is a good place to start when you troubleshoot errors. It provides guidance from the more general to the very specific. One of the first actions recommended by the Troubleshooting Guide is to look for error messages in the AWS CloudFormation console. If the errors occurred on an EC2 instance, you can log into that instance and examine the cloud init and CFN log files. It is common to store AWS CloudFormation templates on Amazon S3, and then specify the S3 location when you choose a template and run a stack. If you receive an error indicating that the template URL must reference a valid S3 bucket, confirm that the bucket exists and that you have permission to access it. Here are some areas to investigate if you try to create an AWS CloudFormation stack and you see an error message that one of the resources failed to create. First, does the user have permission to create that type of resource? Check the IAM policy permissions. Check the level of access that is granted to the user that allows the creation of the resource. Second, verify that there are no missing required parameters for the specified resource type. The easiest way to do this is to look in the JSON or YAML code section in the template where you specify the resource. Then, compare that code against the code that creates the same type of resource and that is known to work. Recall that wait conditions are often used when EC2 instance resources are created. If a wait condition times out or returns an error when you try to create your stack, there is an error in your CloudFormation init code. If the EC2 instance is still accessible after you notice the error, analyze the CFN init log and the CFN wire log for details. You can configure CloudWatch logs to collect the logs from the instance. You could also try running the create stack command again and specify --on--failure do nothing to keep instances from rolling back. This way you can log into the instance and examine the logs. The most common error occurs when files that the CloudFormation init code references cannot be accessed from the instance. Thanks for watching. See you in the next video.
You will now review this module and wrap up with a discussion of a practice question for the certification exam. In summary, you learn about some of the challenges with managing deployments in the cloud. You learn how to use AWS CloudFormation to develop an infrastructure as code solution. You can now explain the purpose and function of CloudFormation and some best practices for managing configurations. Finally, you understand the continuous integration and continuous delivery approach to deploy services and infrastructure on AWS. Great work! You will now analyze a sample certification question. Review the sample scenario and find any keywords that will help you identify the correct answer. The keywords in this scenario are highlighted. You can now consider the answer options. Keeping the keywords in mind, review the answer options and try to rule them out based on highlighted keywords. The best solution in this case are D, tracking the configuration of Amazon Elastic Compute Cloud instances, and E, tracking the status of configuration processes. Now it's time for you to complete the Module 11 guided lab, Automating Deployments with AWS CloudFormation. You will also complete the Module 11 Challenge Lab, Troubleshooting AWS CloudFormation Deployments. This concludes the discussion about creating automated and repeatable deployments. Thanks for watching.
Hello, and welcome to the AWS Academy Cloud Developing course. This module will cover the course objectives and overview, introduce the Café business case, and identify the roles commonly found in cloud computing. This module also includes a scavenger hunt activity that will challenge you to locate materials within the AWS documentation. We'll begin with Section 1, Course Objectives and Overview. Prior to participating in this course, you should have completed a few prerequisites. It is recommended that you complete the AWS Academy Cloud Foundations course or have equivalent experience. Academy Cloud Foundations is designed to provide you with an overall understanding of the AWS Cloud, independent of specific technical roles. The course provides a detailed overview of cloud concepts and core AWS services and their pricing, security architecture, and support. You should also have a working knowledge of at least one programming language supported by an AWS software development kit, commonly referred to as an AWS SDK. The languages currently supported by the labs are Node.js, Ruby, and Python. Experience using an SDK is also recommended. You should also have familiarity using Windows or Linux, the command line, and application programming interfaces or APIs, familiarity with virtualization and distributed computing, version control, and data storage mechanisms such as SQL and NoSQL databases is also a prerequisite for this course. After completing this course, you will be able to recall cloud computing services and models, describe developing on AWS, write code that interacts with Amazon Simple Storage Service, or Amazon S3, by using AWS SDKs, and explain the role of AWS Identity and Access Management, commonly known as IAM. You'll also be able to write code that interacts with Amazon DynamoDB by using AWS SDKs, create a REST API by using Amazon API Gateway, create functions with AWS Lambda by using AWS SDKs, and configure containers. You will also be able to explain caching with Amazon CloudFront and Amazon Elasticache, and develop solutions with Amazon Simple Queue Services and Amazon Simple Notification Service, known as Amazon SQS and Amazon SNS, respectively. Finally, you'll be able to describe the use of AWS step functions, explain how to build secure applications, and identify best practices for deploying applications. This course consists of 14 modules, which are listed on this slide. The upcoming slides will provide more detail on the subtopics each module covers, beginning with Module 2. Thanks for watching, and see you in the next video. Hello, and welcome back for Part 2 of Section 1, Course Objectives and Overview. Let's take a look at the rest of the modules that this course covers. Module 2 introduces developing on AWS and consists of 4 sections and covers the topics of the system development lifecycle, steps to get started developing on AWS, and fundamentals of working with the AWS SDKs. At the end of the lecture, you will complete the lab exploring Cloud Shell and the AWS Cloud9 IDE. Module 3 is storage-focused and introduces the Amazon Simple Storage Service, commonly referred to as Amazon S3. This module also covers creating S3 buckets, working with S3 objects, and protecting data and managing access to Amazon S3 resources. At the end of Module 3, you will complete the lab working with Amazon S3. Module 4 is about securing access to cloud resources. The module covers the shared responsibility model, followed by an introduction to IAM, authenticating with IAM, and authorizing with IAM. Module 5 introduces AWS database options and discusses key concepts for DynamoDB, partitions and data distribution, secondary indexes, and read-write throughput. This model also discusses streams and global tables, backup and restore, and finally, basic operations for DynamoDB tables. You will complete the lab working with DynamoDB in this module. Module 6 introduces you to APIs and the Amazon API Gateway, and you'll learn about creating a REST API. You'll also learn about integrating with API Gateway, deploying an API, controlling access to a REST API, monitoring a REST API, and optimizing API Gateway. At the end of the module, you will complete the lab developing REST APIs with API Gateway. Module 7 introduces you to serverless computers and AWS Lambda, and will cover the topics of invoking Lambda functions, setting permissions for Lambda, and authoring and configuring Lambda functions. You'll also cover the topics of deploying Lambda functions and monitoring and debugging tools for application developers. At the end of this module, you will complete the lab creating Lambda functions using the AWS SDK for Python. Module 8 begins with an introduction to containers, followed by an introduction to Docker containers. You'll then learn about using containers for microservices and will be introduced to AWS Container Services. The final topic in this module is deploying applications with AWS Elastic Beanstalk. At the end of Module 8, you will complete 2 labs: migrating a web application to Docker containers and running containers on a managed service. Module 9 begins with a caching overview, about which you will learn about caching with Elasticache, caching with CloudFront, and caching strategies. At the end of this module, you will also complete 2 labs: caching application data with Elasticache and caching with CloudFront. Module 10 concludes with a lab implementing a decoupled architecture using Amazon SNS and Amazon SQS. In Module 11, you'll learn about coordinating tasks in distributed applications. You will then be introduced to functions and state types. The final 2 sections cover step functions, use cases, and the step functions API. At the end of the module, you will complete the lab orchestrating serverless functions with step functions. Module 12 covers the topics of securing network connections, authenticating with the AWS Security Token Service, or AWS STS, and authenticating with Amazon Cognito. At the end of the module, you will complete the lab, implementing application authentication using Amazon Incognito. You will begin Module 13 with an introduction to DevOps before learning about using AWS Code Services for continuous integration and continuous deployment, also called CI/CD. Next, you will learn about deploying applications with AWS CloudFormation and deploying serverless applications with the AWS Serverless Application Model, also known as AWS SAM. At the end of this module, you will complete the lab automating application deployment using CI/CD pipeline. At the end of the course, Module 14 focuses on bridging what you've learned in this course to attaining an AWS certification. In this module, you will learn about certification and you will be presented with additional resources to help further your certification goal. Thanks for watching, and we'll see you in the next video. Welcome to Section 2, Café Business Case Introduction. The labs in this course are built around a fictional business case. The business case provides a way to explore cloud computing topics in the context of relatable business needs. This scenario is intended to provide an example of the real-world applicability of the technical concepts that you will learn in this course. Frank and Martha had a dream to open up a cafe and bakery after they retired. They weren't ready to live out the retirement around the house. Instead, Frank and Martha wanted to do something that included their love of baking and supplemented their income. They enjoy interacting with the people in their neighborhood, and they like supporting community events across town with their baked goods and coffee. To make their dreams a reality, Frank and Martha recently opened their cafe and bakery. Their daughter Sophia and local school student Nikhil help out and work at the cafe. Since they opened the cafe, Frank and Martha have experienced an increase in local business. They also sometimes have customers who are traveling through the area, either for business or as tourists. Sophia is Frank and Martha's daughter, and she runs the cafe. She manages the supply chain to source ingredients, and she tracks inventory. She took some programming classes in secondary school and plans to start working toward a university degree in business administration later this year. Sophia just learned about Amazon Web Services. She has talked to her parents about how they could use AWS services to automate some aspects of their cafe business, reduce the manual administrative work, and improve the customer experience. Nikhil works at the cafe part-time. He will finish secondary school this year. He works behind the counter to serve customers and do other tasks under Sophia's supervision. He has some experience with visual design, and he wants to learn more about web development and cloud computing. He plans to get a university degree that will build upon his existing design skills and also enable him to learn cloud computing skills. Olivia is an AWS Solutions Architect known as an SA who recently moved to the downtown area. She frequently visits the cafe and enjoys talking with Sophia. Through their conversation, Sophia has learned that Olivia is an expert in AWS and cloud technologies. Olivia used to be a network engineer, and she also has a strong background in database technologies. Faith is an AWS developer who recently completed an AWS internship program. She likes to use her programming skills to apply the appropriate technology to a business problem. She recently achieved the AWS Certified Security Specialty and is interested in developing data analytics solutions. Faith is friends with Olivia and Mateo, and she also frequently visits the cafe. Mateo is an experienced AWS SysOps engineer. He's skilled at bringing automation and fault tolerance to the solutions that he builds. He also likes to design for backup and disaster recovery. Mateo previously worked as a developer and has been a mentor to Faith since she started as an intern with AWS. Mateo is happy to help Faith and anyone who's interested in learning. Mateo is friends with Nikhil, Sophia, Olivia, and Faith, and he frequently grabs a coffee at the cafe on his way to work. In the hands-on labs in this course, you gain hands-on practice building on AWS. Each lab presents new business requirements, which are based on the evolving needs of the cafe. Some labs contain sections where the instructions do not provide full click-level guidance or detailed step-by-step instructions. Rather, you will be challenged to apply the skills that you gained from previous labs and the concepts presented in the lectures. In the labs, you take on the role of Sophia or Nikhil with advice from the AWS consultants who occasionally pass through the cafe. You will architect cloud solutions that help fulfill the business needs of the cafe. The diagram on this slide gives an overview of the application that you will build through the labs in this course. By the end of this course, you will have learned about all the components in this diagram. You should also be able to construct your own cloud application that has as many components as this example. You will see this diagram repeated at the start of most modules in the course. New components in the diagram will be revealed as they are introduced in the course. That's it for this video. Thanks for watching, and I'll see you in the next video. Welcome to Section 3, Roles in Cloud Computing. In this section, you will learn about 5 common roles in cloud computing. You might want to start your career in cloud computing or transition into a cloud computing role. Maybe you would like to work in an organization where some employees have cloud computing responsibilities. For any of these reasons, it is helpful to understand the common job titles or roles that individuals, teams, or departments perform. IT professionals are generalists. They typically have a broad range of skills. For example, they might manage the infrastructure for an entire application and have a strong understanding of the components that make up the solution. However, they might not always have detailed knowledge of any one service that is part of the application. IT professionals are typically highly technical. Common job titles include IT administrator, systems administrator, and network administrator. IT leaders are managers. They typically lead a team of IT professionals and decide on the type of technology that will be used for a project. They might be significantly involved in the implementation details early in the project lifecycle. Then, they delegate the team to handle the details as the project gets closer to completion. Typical job titles include IT manager, IT director, and IT supervisor. DevOps engineers spend their time building out the infrastructure that applications run on. They often create or improve the code that installs and configures servers and application deployments. DevOps staff prefer to experiment and learn by doing. They create repeatable deployment solutions, and they apply engineering skills to the business needs of operation teams. Common job titles include DevOps engineer, reliability engineer, and build engineer. Cloud architects spend their time reading and staying up to date with the latest developments and trends in cloud computing. They're responsible for the design architecture of applications and selecting which technologies should be used to meet the needs of a technical business objective. They should be aware of the capabilities of the many cloud service options that are available. Thus, they can decide which services to adopt given a specific set of business requirements. Cloud architects provide guidance to developers through architectural diagrams and documentation. They also provide tooling, but they give the development team room to innovate if they meet the success criteria. Common challenges for the cloud architect role include resource management, cost optimization, and defining best practices for performance, reliability, and security. Typical job titles include cloud architect, systems engineer, and systems analyst. Another common role in cloud computing is the developer role. Developers like to code. They work with the details, writing, testing, and fixing the code that makes an application work. Developers are likely to borrow ideas from sample code. They work with APIs and SDKs. Common job titles include software developer, systems architect, and software development manager. AWS certification helps learners build credibility and confidence by validating their cloud expertise with an industry-recognized credential. Certification helps organizations identify skilled professionals who can lead cloud initiatives using AWS. The slide shows the AWS certifications that are currently available. To earn an AWS certification, you must earn a passing score on a proctored exam. AWS does not publish a list of all services or features covered in a certification exam. However, the exam guide for each exam lists the current topic areas and objectives that the exam covers. The exam guides and other preparation materials are all available on the AWS website. Note that the exams are frequently updated, and the details regarding which exams are available and what is tested by each exam are subject to change. You're required to update your certification every 3 years. The final module in this course provides more information to supplement what you learn in the course. That module will also guide you in how to apply this knowledge toward achieving the AWS Certified Developer Associate Certification. You will now complete the AWS Documentation Scavenger Hunt. The purpose of this brief activity is to acclimate you to locating information in the AWS documentation, which will support your learning experience throughout the course. Use the AWS documentation website to answer the following questions. First, which section of the website contains links to the supported AWS SDKs and toolkits? Second, how would you navigate to the method for creating an S3 bucket in the AWS SDK for Python, which is called Bodo3? Next, how would you navigate to the Getting Started topic in the AWS documentation for IAM? Which section of the website has a tutorial on how to build a serverless application? And finally, which section of the website provides a link to AWS technical white papers? This brings us to the end of this section. Thanks for watching, and we'll see you in the next video. Let's review what we've covered in this module. In summary, in this module, you learned how to identify course prerequisites and objectives, recognize the Café business case, identify roles in cloud computing, and familiarize yourself with AWS documentation. Thank you for joining us, and again, welcome to the AWS Academy Cloud Developing course.
Welcome to Module 2, Introduction to Developing on AWS. Welcome to Section 1, Introduction. At the end of this module, you should be able to recognize the systems development lifecycle, describe how to get started developing on AWS, identify the benefits of using the AWS Cloud 9 Integrated Development Environment, known as an IDE, identify the benefits of using Amazon CodeWhisper with AWS Cloud 9, develop and run a simple program in AWS Cloud 9, and indicate how to work with AWS Software Development Kits, or SDKs. In this module, you will learn about the Café scenario, systems development lifecycle, steps to get started with developing on AWS, and fundamentals of working with the AWS SDKs. Sophia wants to start developing a web presence for the Café. Sophia has Python development skills, and she's learning more about how to develop solutions in the cloud. Before she starts coding, she wants to decide on a development environment to use to develop and run her code. She decides to explore at least 2 options available on AWS. This diagram gives an overview of the application you'll build throughout the labs in this course. The highlighted portions are relevant to this module. As highlighted, you can use the AWS Management Console to launch AWS Cloud Shell or create an AWS Cloud 9 development environment. With either Cloud Shell or AWS Cloud 9, you can use the AWS command line interface called the AWS CLI, or the AWS SDK for Python, which is called Bodo3, to interact with AWS resources such as an S3 bucket. Thanks for watching, and see you in the next video.